All right, we're back. Forget how it went, but it said something. I forget the lyric. It was something like second verse worse as the first, something like that. Well, this will be second verse better than the first. Hopefully, I don't know about you, but I have I had a shot of coffee, so I don't know. I'm feeling better. But let's go through this introduction to object-oriented programming. Some people are in the breakout rooms, perfectly fine. There's probably like 6 people. They can join when they can, but we're going to move on because we need to. So this is a lot of theory now. This is actually, as I mentioned before, it's object-oriented programming is a very general thing across programming languages. And if you look at the outline, I had only planned to talk about objects, but I can't. When I was doing this, I realized I can't talk about objects and not at least tell you about object-oriented programming. I have to because they're so key. Even if you don't really use object-oriented programming outside of this course, at least when you're working in your blockchain career, you could say, "Oh yeah, I remember a little bit about that." So it's a bit of theory, and it may take a little bit to wrap around your head. I'm not going to get too complex, but it's definitely a pillar of programming, to be honest. So, introduction to OOP. So when you see OOP, that's object-oriented programming. In short, object-oriented programming has been around for a long time. I didn't do the history on that, but I can remember doing object-oriented programming in university, and we had to learn with a language called IBM Smalltalk. You can imagine that. And I have to tell you, I remember taking that course and being like, I don't know what is going on, because it is such a departure from it's a certain way of thinking. And if you're brand new, like, you just take it in as you do with some of these things, right, and absorb it. But this keyword and then inheritance and all that stuff, it took me a while to get. It really did. So again, with anything, you just absorb it the first time, and then as you work with it, you may get it. But it's quite powerful, to be honest. So right. So the basic idea of OOP, which is object-oriented programming, is that we use objects to model the real-world things that we want to represent in our programs. We already established that an object is a real-world item that has properties and methods. Sometimes properties are called attributes, but they're methods, right? We want to represent them in our program, a way to talk about things, a way to have a container or something that we can, in our mind, visualize what it may be like when we're talking about these things, right? And we need a way to access the functionality that would otherwise be harder and impossible to make use of. So if we can think of a car, so we are talking at the object level, but there is a concept which even we will learn in ES6 of classes, right? So we have objects, but there are something called class, right? And we need to at least, get used to this terminology of this, right? So we may have a car object in our head, and then inside of this car object, we visualize, it may look like that, it may not, it may just be an object, but we have the properties or attributes that could be fuel and max speed, which are static, that may be set, but they're internal, right? The fuel, at any point in time, we may look it up and see what it is. Now that may change at any time as well. Max speed is an attribute that changes, right? Can change in different objects, right? Like, so if it was a static max speed, meaning you had a Tesla car versus a Hyundai or something like that, well, at Tesla, the max speed for that instance or that class of car will be greater than that of a small Hyundai, right? So that, although they are both cars, they have different attributes to them, right? In the methods there, you can see we have something like refuel, which is get fuel, refuel, get fuel, set speed, get speed, drive. So we have actions that we can call. But we're just looking at the object itself. Again, it gets bigger than that, but objects contain the related data and code, which represents information about the thing you're trying to model. whether it be functionality or behavior you want it to have. So I think that's a good representation of what an object or class could look like. So we're not going to get too deep in any of these things, but this is actually a very good question that you may run into in any interview. Actually, I've asked this question explicitly because it's good theory, especially if you are working, well, in anything. I mean, maybe not so much in, you know, different, well, people don't know this enough. That's the problem. It's a very good foundation. So you may get somebody who works on Angular or Vue.js or what have you, React. They may not understand this, but it's good to know the concepts because you'll understand things more, why things are being done. So these are 4 pillars. Get used to these words: encapsulation, abstraction, inheritance, and polymorphism. So polymorphism, big word, right? Extremely big word. But each pillar will go through. And I couldn't talk about objects without at least talking to you about this because it's so key in anything going forward. Now, when we get into like Node.js and all that stuff, we may just totally forget about this, but just so you know what they are, anytime you're working on these things, some level of these pillars are going on, right? You just may not know it. Yeah, so encapsulation. So we already talked about local scope in a sense. So local scope and global scope, well, it's encapsulation is a way of encapsulating that local scope. So object data such as functions, properties, those things can be stored neatly inside of it, right? You can picture a capsule if you wanted to. The word is encapsulated. So encapsulate inside of the object package, making it easier to structure and access. Objects are also commonly used as data stores that can be easily sent across a network, like we said before. There's a concept called DTO. You might not know what it is. People just refer to all these short terms and stuff like that. They're just trying to give a reference to a data transfer object that may be sent across the network. Now, this can be many things, right? It could be a data packet. Maybe if you're dealing with, you know, very low level, kind of like not web HTTP, maybe we're dealing at the lower level, and we'll get into networking, right? But lower level like TCP IP kind of connections on the network, right? Or your phone line, your internet connection, they deal with packets. Packets may be, you know, data packet, whatever is in that packet that's being transferred across the network. In itself, it's a type of object itself, right? It may not have. Now, what you do with that packet, that is that's up to the requirements of the system. You may take that packet, unpack it, like unpackage it, and map it to whatever you need to map it to. You might have a big packet coming across a network on those protocols, and you may grab it. It may be very heavy. Maybe you only need to pull out some certain specific information out of it. Therefore, you would quickly make a small little object that you may need, that the only relevant data that you are looking for, maybe it was something like, you know, GPS coordinates, right? You have a huge packet, you just grab the GPS coordinates from a vehicle and you package that up and send it along its way. Maybe you need somewhere down the line to persist that to a database. Therefore, you do what you need to do with the database. Maybe you need to combine it with some other data so you can, you know what I'm saying? Like you get into all these situations where different data stores are being sent all over the place. They're just firing everywhere. Sometimes you combine them, sometimes sometimes you delete them, sometimes you just let them pass through. There's many packets, not only on the network, but throughout your program that are being sent around your application and other mechanisms, right? So it helps to have a lot of attributes, methods, and variables within that package sealed in there and then encapsulated in that package so that only you can access it when needed, right? And there's ways to differentiate some of this stuff, right? So it's called information hiding, right? Because there is a concept in object-oriented programming called, I mean, maybe not so much until we get to ES6, but in most programming languages, right, there's a concept of a public variable and methods, protected methods and variables, and then private methods and variables, right? So as you can kind of tell, right, public is for everyone, private is internal, and protected, I mean, we haven't talked about that far yet, but it basically deals with instantiation, to be honest. So we may not deal with those keywords too much, but there is a way of hiding the information, making it public, making it private. It's hard to, I mean, there's an analogy I remember that's actually I still remember. It's public properties are for everybody. Your protected stuff is for your friends, which is instantiations, and then the privates are for yourself. That's kind of like how it went. I remember. Somehow I got an email, I think, but I don't remember if anyhow I didn't see it flash. So if somebody's asking me a question, I'll have to get to it in a second. But so the concept for encapsulation is used to hide that internal representation or state of the object from the outside world, right? We're hiding it, and only we can expose whatever we want to expose to the outside world, which may only be a very small number of things. We want external. Maybe we don't want to allow the property attributes to be shown. Maybe we only want to be able to let people have read access to it if we have like a method like get full name, or get the diagnostics of the car object, right, or class. So it's called information hiding. When we're building these things, we take these things into account when we're building our object. There's stuff that is very important that only internally to the object you made need to not reveal to the outside world, which may be, for example, some kind of toggle state, or some kind of, you have a flag internally that is something like is enabled or is disabled, or have I iterated through all of the list, or do I have an internal list? Or there's some things that in your working of your code you don't want anybody to see it. You certainly don't want anybody to set it from the outside to blow up your code, so you protect it, right? So there's different levels of what you may want to reveal, and if it's public, you reveal the finished product, right? Just like when we are working with some of the string methods, right? There's a string dot replace, or string dot substring. We know that that's working. We don't know what they use inside of it. It's a black box, meaning the DOM level, the DOM versioning would not reveal something that would allow you to mess things up or confuse you, right? So that needs to be thought out. So the idea of this mechanism is really simple. If you have an attribute that is not visible from the outside world, and you bundle it with methods to provide read or write access to it, then you can hide specific information and control the access of the internal state of the object. Meaning that if you just get full name or some property, that's read only. Meaning the person working with it, or the application working with it down the line and through the network, or your application, wherever it may end up, wherever this object may flow to, you're revealing read-only access to them. Unless you want them to be able to set and modify an internal state, you can restrict the access if you choose to, right? Because you got to remember that this capsule, this packet, could travel many different layers all over. You may want to persist something from the beginning, such as a date time it was created, or a date time that it was updated. Something important like that. You don't want it updated throughout the flow of the application, because suppose it was a profile, like a profile object, a profile for maybe you have a list of user profiles, and you need to know when that profile was created. Now, you don't want throughout the application somebody to edit that created date, because that is a very important date. If you update it to today's date, therefore you may have blown away the fact that he registered or created the account 2 years ago. So you don't want that to be persisted, right? So that would be protection inside this capsule. So we have encapsulation, which encapsulates everything, but we also have the other pillar is called abstraction. And we've probably dealt with some of this already, but it's just a bigger word. So when we were defining that person object we're working with the other examples, so we defined some generic data that and the functionality of a person. So we kind of abstracted or planned only what was relevant for what we needed, right? I mean, there's probably I don't know, a thousand things you could put in the person object, but we basically tailored that object for what we needed, right? We did the first name, last name, we kept it basic and a mechanism to get that out. But there are a lot of things that you could know about a person: their address, their height, shoe size, DNA profile, passport number, significant personality traits, all these things we could have used, right? But we create a template that we're only interested in. So in our case, we were only interested in the name, age, gender, and interests as our template. And we also wanted a little introduction about them based on, data to say hello. So you can visualize in your mind that we have an object that has name, age, date, and we have a function, a greeter function like we had in the past. So that's called abstraction, right? So we basically have abstracted away a simple model for what we need from a very complex thing. So that's called abstraction, abstracting out the details to make a template which best represents the most important aspects that you need to work with, especially for an application or program. So in this example here, we created a person class. Now, we've been talking about objects, right? But objects are instances of classes, right? Really, we have a class. And when we take this class and we create a version of it, or like we create an instance of it, it's an object then. But the defining template is called a class. Again, we may not use this keyword class in this full stack one, but we will certainly use the keyword class in React, because React deals with classes a lot. So in a way, this is like a primer a bit for when we get to full stack 4, which deals with classes, right? And everything we're talking about here today in the theory part will make sense more when we're dealing with them regularly in React, just for you know. So if you look at this class person, now, to be honest, in React, classes may be components of the screen, like a rating component would be a class. But anyhow, we're not dealing with components. We're dealing with the person. So the person class here has a name, has a property, first and last name, which is an array. We care about the age. You can see it's a property in there. The gender, interest as well are properties. We have a bit of a function. We have a function there. It looks like bio, which is it's basically outputting those values. And then we also have a greeting, which we already did, right? We created a greeting in a previous example. It says, hi, my name is whatever. So that's called abstraction. And I was trying to get to this point here because you may not, this is a good representation of what I was trying to explain here. So from our classes, we can create an object instance. So objects contain the data and functionality defined in the class. So we have a class called a car. The car has those properties we already talked about, speedometer, max width, all that, sorry, max speed, and then some actions on it. But we could have many objects of that class, many instances. We could have a Beetle, a Mini, I don't know what a Polo is. We could have a Tesla, right? Those are all still cars. They're all still cars. They're types of cars, right? They're objects in themselves. They may have specific attributes to them only for that object, but they are still cars, right? But they are different objects of the same class of cars. So there's so anyhow, that's their objects and those class. That's basically a way of creating the actual objects. So it's called instantiation. So we've done an invocation, but instantiation basically goes like this. We have the person template, which is the class. When we create a new object, we call it instantiating an object. Therefore, we created an object called person1, which takes the signature or the template from the class, which is person, but then it backfills it with its own details. So it's getting specific now, but it's an object, right? So Bob Smith is the name, 32, male, he likes music and skiing. And anyhow, he has that functional there, right? So we have that object. Now, we don't copy the class again. We just instantiate it, and then we create another class. So this other class is for a different person. Again, this is Diane, age 28, female, kickboxing, brewing. She likes kickboxing and brewing. Well, wow. All right. That's interesting. Anyhow, so you can see here that you have two different people objects, and the attributes remain inside of them, and they need to travel across the network and then hopefully not get modified, right? So if we are creating multiple people objects, again, the class doesn't change, the objects do. And we may create hundreds to whatever our needs are, 1, 2, maybe 100, maybe 1,000, but we refer back to the template, which is the class template. We instantiate new objects. They take on the signature, the general signature of the class, then they give their details, their specific details, specialization or whatever you want to call it, to go across the network. And then again, we control what properties are public, what properties are internal. But from the outside, this is what it would look like, an object instantiation. It's a big word though, but so to break it down, when an object instance is created from the class, so there's a class constructor function is run. We're going to get into what a constructor function is. Basically, it's a way to create an object. So it's a nice way of creating an object for you based on the template. The process of creating that object instance from a class is called instantiation. So again, this is the theory part. You will probably have to study these slides a bit. The object instance is instantiated from the class. So we have a class of car. Those are the instances of the object. They're each different from each other. One's an Audi, a Nissan, a Volvo. However, they are objects, but they all derive. There's another word, derive. They all derive from the class of car. They're all cars, right? They're just different instances of cars. A lot to take in for sure. A lot to take in, but maybe another reference as well. Another person to explain that might help. Let me know if you can't hear this.
A popular interview question concerns the 4 core concepts in object-oriented programming. These concepts are encapsulation, abstraction, inheritance, and polymorphism. Let's look at each of these concepts. Before object-oriented programming, we had procedural programming that divided a program into a set of functions. So we have data stored in a bunch of variables and functions that operate on the data. This style of programming is very simple and straightforward. Often it's what you will learn as part of your first programming subject at a university. But as your programs grow, you will end up with a bunch of functions that are all over the place. You might find yourself copying and pasting lines of code over and over. You make a change to one function and then several other functions break. That's what we call spaghetti code. There is so much interdependency between all these functions, it becomes problematic. Object-oriented programming came to solve this problem. In object-oriented programming, we combine a group of related variables and functions into a unit. We call that unit an object. We refer to these variables as properties and the functions as methods. Here's an example. Think of a car. A car is an object with properties such as make, model, and color, and methods like start, stop, and move. Now you might say, but Mosh, we don't have cars in our programs. Give me a real programming example. Okay, think of the local storage object in your browsers. Every browser has a local storage object that allows you to store data locally. This local storage object has a property like length, which returns the number of objects in the storage, and methods like setItem and removeItem. So in object-oriented programming, we group related variables and functions that operate on them into objects. And this is what we call encapsulation. Let me show you an example of this in action. So here we have three variables: base salary, overtime, and rate. Below these, we have a function to calculate the wage for an employee. We refer to this kind of implementation as procedural. So we have variables on one side and functions on the other side. They are decoupled. Now let's take a look at the object-oriented way to solve this problem. We can have an employee object with three properties: base salary, overtime, and rate, and a method called getWage. Now why is this better? Well, first of all, look at the getWage function. This function has no parameters. In contrast, in a procedural example, our getWage function has three parameters. The reason in this implementation we don't have any parameters is because all these parameters are actually modeled as properties of this object. All these properties and the getWage function, they're highly related, so they're part of one unit. So one of the symptoms of procedural code is functions with so many parameters. When you write code in an object-oriented way, your functions end up having fewer and fewer parameters. As Uncle Bob says, the best functions are those with no parameters. The fewer the number of parameters, the easier it is to use and maintain that function. So that's encapsulation. Now let's look at abstraction. Think of a DVD player as an object. This DVD player has a complex logic board on the inside and a few buttons on the outside that you interact with. You simply press the play button and you don't care what happens on the inside. All that complexity is hidden from you. This is abstraction in practice. We can use the same technique in our objects. So we can hide some of the properties and methods from the outside, and this gives us a couple of benefits. First is that we'll make the interface of those objects simpler. Using and understanding an object with a few properties and methods is easier than an object with several properties and methods. The helps us the impact of change. Let's imagine that tomorrow we change these inner or private methods. None of these changes will leak to the outside because we don't have any code that touches these methods outside of their containing object. We may delete a method or change its parameters, but none of these changes will impact the rest of the application's code. So, with abstraction, we reduce the impact of change. Now, the third core concept in object-oriented programming: inheritance. Inheritance is a mechanism that allows you to eliminate redundant code. Here's an example. Think of HTML elements like text boxes, drop-down lists, checkboxes, and so on. All these elements have a few things in common. They should have properties like hidden and inner HTML and methods like click and focus. Instead of redefining all these properties and methods for every type of HTML element, we can define them once in a generic object, call it HTML element, and have other objects inherit these properties and methods. So inheritance helps us eliminate redundant code. And finally, polymorphism. Poly means many, morph means form. So polymorphism means many forms. In object-oriented programming, polymorphism is a technique that allows you to get rid of long if and else or switch and case statements. So back to our HTML elements example, all these objects should have the ability to be rendered on a page. But the way each element is rendered is different from the others. If we want to render multiple HTML elements in a procedural way, our code would probably look like this. But with object orientation, we can implement a render method in each of these objects, and the render method will behave differently depending on the type of the object we are referencing. So we can get rid of this nasty switch and case and use one line of code like this. You will see that later in the course. So here are the benefits of object-oriented programming. Using encapsulation, we group related variables and functions together, and this way we can reduce complexity. Now we can reuse these objects in different parts of a program or in different programs. With abstraction, we hide the details and the complexity and show only the essentials. This technique reduces complexity and also isolates the impact of changes in the code. With inheritance, we can eliminate redundant code, and with polymorphism, we can refactor ugly switch case statements.
It's it's actually very true. When you're building object-oriented code, it takes a lot of thinking and planning. To be honest, it's a lot of you find yourself rebuilding and refactoring quite a bit, and you can eliminate a lot of code, and it's always, you know, like you're always tailoring some of the code and cleaning up. It's quite a bit of work, but it saves you in the long run because it's like building Lego blocks that you can reuse as you go. I think I remember when I started, I think in university, I remember doing Pascal and COBOL. It's old school, but it's like procedural language. This is what it looks like. And it looks like this, like it's thousands of lines of code that it just flows, right? Thousands of lines of code that try to find an example for you that makes sense. But there's a lot of concept of go-to statements, and basically you have one code piece that you know, as you're traversing down, you go through. Okay, so go back. So think of a giant file where all the code exists in one file, and the only way to navigate around is using go-to statements. So you can imagine the type of work that goes in. Now, not that being said, it's extremely fast. It's very fast, but there's a lot of spaghetti code in there that there's not a lot of reusability. That if you remove a go-to section, like you can break the whole thing. So it's hard to maintain, and it's a lot of work, and it's very procedural, right? You do this, you go to the next section. You do this, go to the next section. It's just hard to, like I said, it can grow to like hundreds of thousands to not only millions of lines of code, and it's not really reusable. It's hard. It's basically really difficult to it's really difficult to really maintain a giant application. With that being said, before I knock it completely, I do know that I think it was someone, my father-in-law's brother, actually. He was a programmer in COBOL, and he was working on the Interact system in Canada. We have Interact between I don't know what it's called anywhere else, but maybe it's called Interact. But it's you can use your bank card at any bank. You can use your credit card at any bank, pay anywhere in any store. It deals with the transaction. The backbone of that is, he told me, it was built in COBOL, and it's lightning fast. I tried to knock it, and he said it's been there for many years. It's really fast. Why would they want to change it? And maybe that's true. He just said it was very difficult to maintain, but it works and it's fast. So, but they got to throw a lot of money at it to keep it running. So all I can say is a system like that that's been written for like 30, 40 years, is hard to replace because there's so many lines of code and dependencies. Whereas if you have something like object-oriented programming, you could swap it out with a new replacement very easy, because you could swap out the pieces of all of that, not just the whole thing. So anyhow, the maintenance would be way lower. The price to get people in there and consultants would be way lower. Everything would be probably, save millions. But I can't knock it because it's still out there. So anyhow, it has no concept of inheritance. They have just go-tos. But here we have a concept of inheritance, right? So as you already know with the word inheritance, right? It can be, as you have a parent would basically pass down their inheritance to the children. It's the same way, right? So in this case, we don't want generic people, we want teachers and students. So using our example that we looked at before, we may want a situation where we don't just want people, we want more specific types of people. We want teachers, students, all these other types of people, right? In object-oriented programming, we create that class. So we can create a class based on another class. So this is where things get weird, right? You can derive, it's called derive, when you actually make that, so you make the instance of the class, you can actually make another object of that one you just created. And this is where it gets a little bit interesting, right? So in object-oriented programming, we can create a new class, we can create new classes based on other classes. So if you have a person class, you could then create 3 different types of persons, teacher, student, and whatnot. So these new child classes can be made to inherit the data and features from the parent class, right? So we'll get into what that person abstraction, derived or inheritance look like. But you basically want to reuse the common functionality rather than having to duplicate it all the time. As in the example the guy had, his name's Mosh actually. You have an HTML element, which is the parent, but then you have 3 separate child classes that are all still HTML elements, button, text box, or whatever. They all have their own specific internal information. However, they all share some common thing like render. They all share it because that's the class that they were derived from. They inherit the render method, so they all know how to render, but they're just different types, right? So instead of going to each object and adding that functionality, you can inherit that functionality, so then you can basically have cleaner code, right? So a simpler version of inheritance was you have an animal that has characteristics, you create a dog or a cat, they inherit the distinctions of an animal, right? That, simple as living, breathing, sleeping, right? A dog and cat both do that. However, the difference between those two is a dog is still an animal, but it may bark. A cat, still an animal, but it may meow, right? Like they have different specifications to each of those objects, but they inherit from the parent, right? Again, different way of thinking. I don't expect everybody to get it. I remember when I first was trying to learn this stuff, it really, it took me a while, to be honest. So if it does, and you're not used to thinking this way, don't worry, but it's good to expose yourself to it. So getting back to that, with a functionality difference between classes, you define specific features directly on them as needed. So let's look at that person object, I believe. Yes. Right. So we had that person template, the class, right? The person template that has name, age, gender, bio, interest, and we want to create kind of a more specified version of it, still maintaining, as you see, you have a teacher class. It's still, we can say inherits from the person, the same properties there in these brown sections, right? They all have name, age, gender, interest, and bio, but they're not re-implementing it every single time. They're basically inheriting that information from the template, their parent template, and then they're adding something specific to them. So in the teacher has a subject, a property that is only required for the teacher object. The student doesn't have a subject, right? It's not teaching a subject. It doesn't need that specialized property. So therefore, it doesn't have that implementation. However, they both carry forward the template of the person class or object, right? And the power and the flexibility of this is there's no limit now to the type of people that we can create. We can create however many we need, right? We could create from 10 to 1 million types of classes, but they will all inherit from the parent template, which is a person. And every one of those child classes before, when they're instantiated, they're objects, but the child classes all inherit that. Throughout that, if they reference that template. So it's a way, and the other powerful thing about that is that if they all inherit from the person template, and you have 1 million, or it's not 1 million, you have 1,000 classes, they all have a common greeting. If you need to go and make a change in that common greeting for whatever reason, maybe you want to add a timestamp or something, you just need to do it in one place, which is in the parent. And then therefore, all those 100,000 child classes will all get that fixed because they all point to the parent template. So you only have to fix it once, you don't have to fix it 100,000 times. And that's the power of inheritance, right? So put that in your hat. Another very interesting, and very, it's a big word, but if you just understand that it means many forms, you'll kind of, you'll break it down in that sense, right? So polymorphism is used in various contexts to describe situations which something occurs in several different forms, right? Many forms. In computer science, it describes the concept that objects of different types can be accessed through the same interface. So we have a person, we had teacher, student, and whatnot. Here we have a shape. So the shape would be square, circle, triangle, and pentagon, right? They're all different specifications of a shape, but at the end of the day, they are still a shape. They may have specific properties to them, but at the end of the day, they could all be, I guess the area of them or can be calculated, right? Sorry, I'm already forgetting my math, but anyhow, they have a common functionality that can be used, right? Going back to our list here, they all are still, so here's an example of many forms, sorry. We have the teacher class, we have the teacher object 1 and teacher object 2. So they're all still relatively, they all could be considered a class of teacher. So they have many forms. Now, each of the details in them change, but they're still the same specification of a class, which means you could grab any one of these. Doesn't matter if there's 2 or there's 100,000. If you call a greeter method on it, it's all going to work. So it's basically many forms of the same class template, which is teacher. That's what polymorphism is. It's many forms, and it's a big word, but if you think of it in that way, you'll get a lot farther. So big words for sure, right? So there is a concept. So now that's kind of like so that is really kind of like the theory part of it, and that's a good lecture on theory. There's a lot more, and it gets very complicated, especially how you do inheritance and all that stuff in JavaScript. Now, I'm not going to, at this point, get into that because it's a bit confusing even more. I'm not going to confuse you anymore. When you get into ES6 syntax, you start to see those keywords we just talked about, like class and public and private and those kind of things. You get to see them and you think in your head, oh, like it's like object-oriented programming. Now, that's what the advantage is because it makes you feel like you're programming in an object-oriented language. When in behind the scenes, JavaScript is doing a whole bunch of crazy stuff to make it appear that way, which we don't need to get into that crazy stuff right now, but we at least will touch on it at some point. But anyhow, so now we can circle back and talk about objects again, because now we kind of have a concept of the whole bigger picture, digest it a little bit. The lab questions and what we're going to ask isn't going to deal with too much of that crazy stuff right now. So, but if we're talking about objects, there's different ways you can create them. We were looking at object literals, but there's something called a constructor function that you can use to create your objects. Right, so JavaScript uses these special functions called, and again, could be ES6 again, constructor functions to define and initialize objects and their features, right? It's useful because you may come across situations where you don't know how many objects you're going to create. It's true. We've just been dealing with that person object, but we don't want to keep doing object literals all the time. It's very costly. We would want to build, like we said when we were first established what functions are, we want to build a piece of reusable code that does something well, and we keep it in scope, and we can always use it again, right? So if we have a constructor function for person, and we know it works, we can use it and keep it in memory as a utility or whatnot. And anytime we need to create that person object, we call this special function that'll build it for us every time. So we don't have to do all that long lines of code. We do it once, it works, we get it working, then we save it in memory, we have a reusable piece of component we can use throughout our application. So that's what like a constructor, not constructagon, like transformers, but constructor. So constructors provide means to create a new object as you need them in an efficient way, attaching data and functions as required. So there's two patterns we're going to look at, and really at the end of the day, they're just functions. But you can see it in a way that it abstracts the way of creating those objects for you. So if we wanted to create that person, we could do it in this way. We could have a function that just says create new person. We give it a name internally. It creates the object for us, this empty object literal. It assigns the name, so it creates that object. Everything we did we did it externally. In the other example, we're doing it inside here. We have our greeter function that we wire up again inside, and then you can see here that it's not referencing this at this point. We're using the object itself, right? And then we return it. So if we call this from the outside, we create a variable called Mike, create new person with Mike. It's gonna go and give me an object back. I can do whatever I want with that object, pass it around. I can invoke the greeting on it, and I'm good. That's called the factory pattern. So there's only two patterns. They both use functions. So one looks like this one here. So if I have an animal, I create a new object here, and then same thing, I assign the name. I call this method called identify, and then I can create a couple animals here and invoke it, right? I can invoke it from the outside. So if I output this and run it, my expectation with this would be that it would internally go and run it and not crash. I'm Tom, I'm Jerry. Right, if we actually console log each of the objects to inspect them, to see what they look like, right? Oh, sorry, you have to instantiate it first. We have two objects here. We want to console log each of them, and maybe the name itself isn't actually a good indication of what it is. Maybe you might want to add, a camel case like Tom object, just so you know what it is. But if we run this, you can see here we have the object literal, which is the object, and then we have the short form of the object. We have the name Tom. You can see we have that function in there that's already built for us. So that's great. So then all we need to do is from externally, we need to invoke it, but via identity, and then it'll do the invocation for us. At the same time, so it's returning to us the property in a way that we can access it directly. We're accessing it through this invocation here, which is really great because it's just like using the string methods, right? The same way, you have a string. On that string, you have length, or you have substring, right? So if we have a string, whatever it is, X, I don't know, it's terrible, but my string, it's an object now internally. We have all these methods on it, right? Substring. In the same way, all of those methods at some point have been added similarly in this way internally to that piece. So this is called the factory pattern. So there's another pattern that we may look at that is kind of the same. It's probably a little bit nicer or cleaner. It's called the constructor pattern. So
I have a
yes,
question.
yeah,
So regarding the factory pattern, I mean the way the function has been declared, it's kind of using hoisting. So is that like the part of the design, or we are free to declare a variable and then do a function declaration to that?
yeah, for sure. You can do a declaration as well. Like this is, yes, for sure.
Okay, thank you.
Yeah, I mean, to your point, sometimes we get lazy. Even myself, I'm like, oh, I don't want to type it all out. But to be honest, this is probably the better way to do it. Um, yeah, this is probably the preferred approach to do it, right? Or going this way. When we learn ES6 syntax, we won't have to do this whole long form anymore either. But yeah, that's probably much better, right? To do um, in that sense for this scenario, it's better. However, I would probably prefer, I would probably prefer to use the other pattern better. This constructor pattern, I think, is nicer. So the constructor pattern looks like this. So it allows you to create a custom constructor function that defines so same deal, creates a method for you. Sorry, an object, but it starts with an uppercase. That's the only difference. So it signals the JavaScript you want to create this object, right? So it'll know that you want an object. So this is now an object. So if you see, it's a lot smaller. It has this keyword in there. So now you look at that code, it's so much cleaner. So now we could actually new it up. New it up means we actually provide the new keyword. I like this way better. Internally, again, JavaScript knows what to do with this pattern. So if we wanted to, let me quickly just give this, show this code here. Constructor pattern looks like this. So if we have an animal, again, I didn't do this. I should probably do it in this way, right? Animal equals function and like this, and see if that still works in the same way that we expect it to. Should. So if we run that in our playground, we can take a look at this. By the way, someone remind me, I'll upload, I'll upload these solutions to the repo when I give you time to work on it, so you guys can look at the examples as you're doing the lab. Probably helps. Right, so it doesn't really matter if we do it, but it knows that if it's uppercase and it's a function, it's probably going to be an object, and you can use this new keyword to new it up. And again, if you're looking at the difference of syntax, it's a lot. If we were to just look at, if we were just to look at, we'll just remove this for a second here. If we were to look at this animal function here with a name and identify compared to this one, well, you see there's a lot more going on in here with the object, right? Still valid, still fine, but it's a lot less code. It's just using this keyword, it's cleaner, and it has a this, and it wires up the method, right? This is called a method. Even though it's a function, this is the method, the action that we take on the object. And then you knew it up in the same way you would an object, right? So if we actually outputted, Donald Duck, by the way, if you don't know who Donald Duck is, or Daffy Duck, or any of those, look it up. Same way, we have this, but if you notice here, it's giving you a different, it's giving like see if you notice it's an animal object. In comparison to the previous way we did it, it actually was an object literal. So now it's actually saying that this is an animal object. So it's identifying that it's an object, and it's actually giving it like a type. So to me, this is like a preferred approach, but the other approach is fine too. It's perfectly valid. Just again, a lot less code, very concise, very clear. We give the indication with the new keyword that it is in fact a new object, just in the same way as if we had the long way, right? We had the long way previously. We had a string, which will convert it to a string. But however, if we signaled that we want that wrapper, that string wrapper object around it, then we may do it in this way. And this right here looks like this, right? In the same syntax. It's a new object of string type. Therefore, it comes along with all of those new, all those fancy features. So you can do it in two ways. There's two ways you can do it, but this one's certainly a lot cleaner and nicer.
So, Mike, the process of capitalizing the first letter of the this declaration, is this more of a convention, or does it have uh, any other processes or any other um, I'm not finding the right word, but does it like influence the compiler in any way, or like the opposite of it, or is it just for the reference for
it's
like a convention?
yeah, they're both very similar, and when you it's mostly in the compiler. It's mostly in the compiler. See, with ES6, when we get into it, you're going to see that there's such thing called a syntactic sugar, meaning JavaScript tries to give us better ways of telling our story. But at the end of the day, the compiler, it's all the same to the compiler. It breaks it down in the same way. It doesn't. At the end of the day, it's the same code, but they try to give us tools in order to make us feel as if we're programming in object-oriented programming, or we are doing things that make more sense with traditional languages. But just know the fact in behind the scenes, it all ends up the same. If that helps at all.
Okay,
It
so I mean, for example, the in Visual Studio Code, right? If you're trying to do a particular statement, then it would recommend some alternative ways to do that. So the way in which it tries to jazz things up a bit, uh, is it like making some suggestions if we code it in this way, or
No, not really. It just knows that you're trying to you have access to the keyword. So there's actually something called a Babel compiler. So the Babel compiler will actually compile down your JavaScript. So and I have to when I start working with so this is a React component actually, but when I start getting into ES6 or ES 2015, you'll see that you may I'm not set up for an example, but you'll see when you run it through this compiler that at the end of the day, it'll all compile down to the same kind of crazy code, whether you do it the long way or you do it the short way. So they're giving us um, shorthand ways of doing the same thing. Um, and if you come from a traditional programming background, this makes a lot of sense internally to me as to what it is. It's an object, and this keyword is in play, and it's very concise. This to me is longer, but it's not wrong. This is perfectly right. If you if if you feel more comfortable and confident in this way, perfectly fine. This is vanilla JavaScript. This is just the next level. Same way of doing the same thing, but you just get more. You might get more in this way because you have this keyword and you have access to now it's an animal type. But Visual Studio Code will not reject either of these. It'll just basically compile. The browser will compile it down to the same thing at the end of the day. So it'll make more sense when you learn ES6 tomorrow night or 2015 or those schematics. We'll run through some things through the Babbler compiler. That's the thing that compiles down the JavaScript for the browser, and you'll see it work. To be honest. Um,
thank you.
Let me see if I can run it quickly. Am I still using, let me see here, let a equal to 5. Right, as you can see here, right? So we have our normal var keyword, but we're using the let keyword, right? So when it translates down to this. So let me take this thing here. Let's see what it looks like when it compiles down. So if I use this code piece here that we just wrote, it compiles down to this. So actually, it does compile down to a var keyword, and I guess internally it actually knows about this keyword. So it does have it as part of the markup compared to, so this is actually a good thing to run here, compared to this pattern here. Let's see what this looks like. So this converts it down to what it is. So it is objects in itself. So now that's ES6, ES6 loose, stage 1. So there's different mechanisms. So ES6 knows what to do with that. So at the end of the day, they do the same thing. But again, it all depends on where you're coming from. So for me, this constructor pattern with the this keyword, it gives it an animal type object. I like this. I like this automatically. This is a lot more work. It's a factory, right? You're creating an object every single time. Whereas behind the scenes, the object is being created for you. Again, 2 patterns, same thing. I like this one a lot better. Internally, it knows by the signal that this is uppercase, that's an object. So it's these are tools, whichever one you want to use, to be honest, is the best approach. We'll probably get a video at some point on this, so you know what, maybe they would add to that as well. But I'll just read this script here, and then we'll see if it answers any further questions. Constructor function is Java's version of a class. Notice it has, well, that's a good thing. Notice it has all the features you'd expect in the function, although it doesn't return anything or explicitly create the object. It basically just defines it. So it's defining a class, okay? Notice also this keyword is being used here as well. It's basically saying that whenever one of these object instances is created, the object name property will be equal to the value passed in the constructor, and the greeting method will be used to pass it on. So it's signaling a class. Okay, cool. So let's look at a video on this constructor as well, because I knew that this would mean a little bit more. So let's take a look at this. Babel compiler is really cool. We'll look at that as well, especially when we get into React, because there's a lot of transpiling that goes on.
All you need to launch a code.
Sorry about that, until I can skip it.
You're watching JavaScript for Beginners lesson 30, and in this video I want to introduce to you the constructor function. Alright then class, so in previous lessons you've seen me create objects like this, something to do with my car, and then we've given it some properties, the max speed and driver, and a couple of methods also. Now if we wanted to create variations of this my car object, for example my car 2, 3, 4, we could technically copy this and paste it down here, call this my car 2, we'd go in and change our properties, then do the same, my car 3, change the properties, and so forth. But say we want to create 30 of those, or 50, or 100 even. That is going to take up a lot of room in your JavaScript, and it's also going to take you a lot of time. Okay, so there must be a quicker and better way to do this. Well, my friends, there is. It's called using the constructor function. So, what is a constructor function? Essentially, a constructor function is just a function that creates an object for us, right? And we've seen them in play already, kind of. When we do something like this, var my array equals new array, that's creating a new array object for us, a new blank array object. And this right here is calling the array constructor function to create that object for us, like the same we do with strings. Var my string equals new string, right? That's doing the same thing. Constructor function to create a new string object. So what's to stop us in JavaScript doing something like this? Var my car equals new car. Absolutely nothing. We can create this constructor function car to create those car objects for us, right? So we could do this if we have 1 car, if we have 20 cars, we can call this every time, right? So that's what we're going to do. Now the first thing we need to do is make our variable to store the car constructor function in, and we're going to call this car, and you'll notice that I'm starting it with a capital letter because that's generally how we do things when we're creating constructor functions in JavaScript. They all start with a capital letter, generally speaking. So we're going to set this equal to a function, and we'll open our code block right there. And then within these parentheses, we're going to pass in a couple of variables. And the variables are going to be used so that we can set these properties, the max speed and the driver. So we'll simply call them max speed and driver. Makes sense, right? And then we can access those variables in here. So when we create a new car, we could say my car equals new car, and then we pass in the two variables here like 50 and Ninja. And those variables are going to get passed into these variables here, 50 and Ninja. So that's how it works. And then within here, we can use the this keyword. We've already talked about the this keyword in the previous lesson. If you've not seen that, go back and check it out. But you know now we can use the this keyword within this function to represent the object that we're making, right? Because it owns this space. So we'll say this dot max speed equals max speed. And that right there is going to be the same as saying whatever variable we create, say my car 2 or something, dot max speed equals max speed. And it's going to grab this value and set it equal to that property there, right? So we'll just keep this as this. Then we'll do the same for driver. This dot driver equals driver. It's going to grab that variable right there that we pass in and set it equal here to that property. And then we're going to do this dot, what's the first method we have? Drive equals, and then we're just going to grab this function here, copy and paste that, and put our semicolon at the end. So that's the drive function where it's going to log the distance traveled. Then we'll do this dot log driver, and we'll set that equal to this function right here. Copy and paste it in. And that's going to log the driver name out using this dot driver, which we've already set up here. And that's all there is to it, guys. That is your constructor function right there. We've got our properties set up and we've got our methods set up. Now, the only thing left to do is call that constructor function and set it to a new variable. So we'll do, I'll tell you what, first of all, we'll delete that and then we'll create a new variable called var my car equals new car, and then we'll pass in some variables to these here. And the max speed is going to be 70, and the driver name is going to be Ninja Man. And we'll do another one. Let's just copy and paste this a few times. My car 2, my car 3, my car 4, and we can go on and on however many times we want to, and just pass in different details in here each time. That's how easy it is now, guys, to make a new car object. Then we can just pass in new names as well. Humpty, Dumpty, Sean, and why not, let's pass in James Bond. All right then, so we're creating 4 new objects, and we've only created this constructor function once, so a much more efficient way of doing things, I think you'll agree. And let's just test this. Let's just log a few details out of these cars. We'll say, first of all, my car.drive, and we'll pass in 30 miles an hour and 5 hours. Then we'll say my car 3.log driver. Okay, let's just test those out. Refresh over here. So 150 we're getting first of all, which is 30 times 5 from this function. So that's cool. And then my car 3.log driver is giving us driver name is Sean, which you can see here in my car 3. So that's all worked perfectly. So guys, that is the constructor function in a nutshell.
Actually, if he actually tried to call like mycar3.drive without parameters, it would not pick up 150. It would be undefined because you didn't pass anything in. So each of those instances of those classes have, you know, obviously retain their own local storage or their own local scope. So when you give the first one 30 and 5, all 4 of them won't get it. Only the one that you actually interacted with will. So interestingly enough, he didn't show the factory pattern. And what I can tell you is you got to remember the different versions of JavaScript. This to me is very older. I remember this one. This one to me, even when I look at it, something like this, it just seems to me like very recent, meaning when I mean very recent, like the last 5 to 8 years. So I've been looking at JavaScript for a long time now. So it's just a difference of doing it. the newer versions of JavaScript will have a lot of interesting keywords that make life easier for you, right? So think of it as a newer version of it, of the syntax. And when we get into ES6 tomorrow, you're going to see what I mean by that. There's a lot of different newer syntaxes that we can now start playing with. That'll make our life a lot easier. So I'm going to stop recording.